This experiment is for continuously mixed flow reactor or Cmfr lab. I have the sodium nitrate standard S1 to S5. The pink solutions are potassium permanganate standard S6 to S10. This is 3 molar sodium nitrate, which you will add about midpoint of the experiment. This is potassium permanganate. This is the solution we are going to start the experiment with. But before we can start pumping the potassium permanganate, we have to measure the flow rate and the volume of your reactor. Now this is your reactor. You have it. I have it under mixing condition. You can see the magnetic bar spinning there. I have the stir plate set at 2. That mixing speed is sufficient enough. You don't want to mix too fast where you can see this vortex, which is small. If you spin it too fast, you will make a deep vortex. We don't want that to happen. So this mixing speed is sufficient enough. Now to start the pump, I'm going to turn it on here. And then there is a start-stop switch. I have to press this one to start the pump. Now water from the distilled water is going to flow through this tubing. And it's pumped into the reactor. Now you want to pump enough to allow this water to overflow. Now we are going to measure the volume of this container under overflowing as well as mixing condition. You have to do this 3 times. The water is about to overflow, and you can see that it is flowing out now. At this point, I'm going to stop the pump, come back over here, use this 1 liter graduated cylinder to measure the volume of the reactor. I'm going to turn off the stir plate. You can see the magnet stop spinning. Now carefully lift this one. You may end up spilling some liquid, but try to avoid. I lost some here. So if 2% can do this, it will be a lot easier. So pour it in this graduated cylinder. You can bring this back here. Now I see the volume is about 260, and I spilled some water here. It's possible that I spilled some 5 milliliters. But if 2% can do this one, you may very well be able to do it more precisely. So do this part 3 times. You can pour this water back in the reactor. So it looks like I don't lose too much water. This is the water I spilled. Again, if 2% can do it slowly, you probably can avoid spilling water. The reactor, try to keep it in the middle. Now turn on the stir plate, and I'm going to set it at 2. So you want to measure the volume 3 times, and we will take the average volume. The second part is to measure the flow rate of your pump. Now go back again, turn on the pump. Now instead of draining the liquid into a reactor, you can drain it in this 100 ml graduated cylinder. And I'm going to keep it like this. I'm going to fill for 1 minute and see the volume collected. So in about 1 minute, I collected approximately 58 milliliters. So the flow rate is 58 milliliters per minute. Again, you want to do this 3 times. Measure your volume 3 times, measure your flow rate 3 times. Once you're done with volume and flow rate measurement, these are your sample containers. They're called cuvettes. You want to hold them at the edge, avoid touching the sides. Bring it here. You want to collect a blank sample, a sample with just water. So to collect the sample, I would keep it like this and hold it on the edge. The sample will flow in. You can see that I collected it. I'm going to do it one more time. So hold it at the corner and we'll collect the sample. So this is my zero sample. This sample will help us to blank the instrument to measure absorbance as well as to use for our time zero reading. After you collect your time zero or the blank sample, now we are ready to start pumping potassium permanganate. I turned off the pump. Now you want to take this tubing and put it inside this potassium, open this parafilm, put it inside the potassium permanganate solution, and then come back here and turn on the pump. As soon as you turn on the pump, one person in the group want to pick a cuvette and start collecting sample. You want to start collecting sample at 1 minute interval for next 90 minutes. Now for the volume, 265 that I measured and 58 milliliters, the flow rate I measured, the time it takes for potassium permanganate to reach the reactor and the reactor concentration to be 85% of the concentration as in this solution. So it will take 9 minutes. I have a spreadsheet in Moodle which is named Cmfr time calculation. If you enter your measured reactor volume and the flow rate, you will see the percentage of potassium permanganate in this reactor versus time in that spreadsheet. So adjust the time or keep changing the time to get the time for the reactor concentration to be 85% of what is in the pre-made potassium permanganate solution. Now at that point, you're going to add sodium nitrate. Sodium nitrate is right here. Use a pipette, and to use a pipette, if you press yes, it's going to pull liquid. If you press E, it is going to empty the liquid. Now I'm going to use it here. This is just distilled water. I'm not taking the sodium nitrate. I'm going to press yes. You can see the liquid is coming up. My measured volume is 265 milliliters for the reactor. So I want to add 2.65 or about 2.7 milliliters. What I'm going to do is take up to 3, come back here, go to the middle. Since I want to add 2.7, I will start at 3 and then go to 4, 5 and 5.7. That will be my 2.7 milliliter volume. So I start at 3 and I'm going till 5.7. So I added 2.7 milliliter of sodium nitrate. For the next 3 minutes, collect sample at 1 minute interval. Again, collecting sample, take one of these cuvette and keep it in an angular position. Keep it right here. It's going to collect your sample. Now this is water, so you see it is colorless. But once you start pumping potassium permanganate, it's going to be pink. So after adding sodium nitrate, for the first 3 minutes, collect samples at 1 minute interval. And from minute 4, after adding sodium nitrate, take sample at 3 minute interval. You want to take samples till 35 minutes. I added sodium nitrate. By my calculation, sodium nitrate should be added at 9 minutes. I'm collecting sample for 26 minutes after adding sodium nitrate. Again, After adding sodium nitrate, first 3 minutes, take sample at 1 minute interval, and then take sample at 3 minute interval till you reach 35 to 36 minutes. All the samples that you collect, you want to put it in this container. So if this is one of your sample, you want to keep it right here. That way you don't spill it outside. Now, this box, you may want to give some numbering system. That way you know what sample is collected at what time. And again, I said the time interval. Before you add sodium nitrate, you're taking sample at 1 minute interval. You don't have to be precise at 1 minute, but you need to know what time you are collecting. Meaning it can be 60 seconds, 70 seconds, 80 seconds, that is fine, but note down the time you collect your sample. Once you collect your sample, arrange it here. The standards for sodium nitrate and potassium permanganate. Pour the standards in here. So you will need 5 cuvette for potassium permanganate and 5 for sodium nitrate standard. So you'll have 10 cuvettes with standards, and depending on the time you collected your sample, you'll have about 20 to 25 cuvettes for your samples. You will measure sample absorbance at 2 different wavelengths. This is the spectrophotometer you're going to use for absorbance measurement. You can measure the absorbance for 6 samples at a time, but what you want to do is, if you see there is a numbering system, 1, 2, 6. Now cuvette number 1, always put the blank or the distilled water sample that you collected at the very beginning, and use the other 5 position to measure the absorbance in your sample. So there is an on-off switch right in the back. I'm going to turn it on. When you turn on, you have to keep the lid closed and the software program will load. It will take about a minute or so to go through different checks in the instrument. So the instrument finished the calibration. The default wavelength is lambda 600 nanometers. Now we are going to measure the standards as well as all the samples at 2 different wavelengths. One is 300. Now to change the wavelength to 300, you want to press this arrow right here, which corresponds to, I'm pressing the third arrow, which corresponds to single lambda. Press. Now the instrument is set to measure all the samples, 6 samples at a single wavelength. Now the wavelength default is 600. We need to change that to 300. Again, press the third key, the third arrow, which is go to lambda. I'm going to press it. Once you press go to lambda, it allows you to change the wavelength. I'm going to press 300 and press enter. Now the lambda is changed 300 nanometer. The spectrophotometer works based on a lamp or a light. What you want to do is, if your experiment is going to run for 36 minutes, at about 30 minutes, come back, turn on the machine, allow it 2 or 3 minutes to go through the system check, and then change the wavelength. Give it 2 minutes before you start measuring your samples. So if you see here, 0 is number 1, read 2 to 6. So inside this one, in position number, in here, position number 1, use always distilled water. Do not remove that particular cuvette. Now, cuvettes in position numbers 2 to 6, you can keep changing it. Measure all your standards, samples. And before you put your samples in the spectrophotometer for measurement, the cuvettes, use a Kim wipe and wipe the outside. You may have your fingerprints or the water that spills on the sides, so clean that before you put it inside the spectrophotometer. Once you're done with that, you can go back to lambda again and change to 525 nanometers. I'm going to press 525, enter. So the wavelength changed to 525. Now again measure all the samples and standards. So your samples and standard, you will measure at two different wavelengths, 525 and 300 nanometers. You can do it in any order. You can use 300 nanometers first, measure all the samples, and then go measure at 525, or use 525 first and then 300 nanometers second. Be careful that whatever wavelength you choose in the beginning, make sure you measure all the samples in that particular wavelength, and then switch the wavelength, measure all the samples in the second wavelength. Do not keep changing wavelength in between sample. That will take you too much time.